Good afternoon. This is Nick Mosley. UTC ID is KHY111. This is coding problem set 5, the Caesar cipher. This will be problem 1. I'm going to go ahead and kind of get some clerical stuff out of the way, I guess, here. Um, Per usual, we were given some predefined functions here to help us with the Caesar cipher. So, for example, this is loading all the words. There were over 55,000 predefined words or preset words here in a Word file. We've also got this function, which is going to see if the word is a valid word. It's going to ignore capitalization and punctuation, which is very nice for our purposes here. Excuse me. This one is going to return a joke in encrypted text, which is going to fall under, I think, problem 4 or 5. Don't recall how it's broken up here. This will be the actual word text that we're going to be pulling from. This will be this will be a class, obviously, here, message that has been predefined here to set the actual message text here, and then to load the words to see if they're valid here. Check the validity of the words there. This is just going to be returning a lot of the parameters that'll set this here. So the message text, getting that here, getting that list of valid words, and then copy there. And then what we were tasked to do for problem 1, we needed to build the shift dictionary. And what we were looking to do is create a dictionary that can be used to apply a cipher to a letter here. It needs to do uppercase and lowercase letters, 52 total, which will be A through Z if uppercase and lowercase here. We need to apply the shift amount to define that shifting dictionary here. And then we've got to return said dictionary with the definition of the shift here. And so what we did, set this to an empty dictionary set. We're going to take a look at the range of letters in this list A through Z. We're going to take the letter, so I in this case is going to be A, apply the shift. So if the shift is 1, A would become B. If the shift is 2, A would become C, so on and so forth. And then we're going to modulo it by 26. I don't know if modulo it by 26 is correct terminology, but yeah, essentially we're just going to make sure we stay within that function of A through Z and don't go overshoot. So, if somebody, was added a shift of like 1,000 or whatever, we would just return that remainder here. And then similar case here, won't bore you with this, but yeah, functionally the exact same, just it's going to do that same action just for uppercase letters, and then we're going to return that dictionary. So essentially, we'll predefine that shift. We've got some testers. I mean, I've done a Caesar cipher, excuse me, with user input, which would do do variable shift, but for our purposes, all our testers are predefined here with the shift amount, which is nice here, and then we'll return the dictionary that's been mutated here by this dictionary set. And then this here is going to actually apply the shift to the actual message text here. That again we're given by the predefined testers here. And then so we're going to shift it down to the by the shift amount here, frankly, based on the integer. So what I did here is set a variable that addiction that is going to call back to that built dictionary. We're setting crypt to the actual text of the message here. And then we're going to, for each of the letters in the dictionary, we are going to go through the actual message, and then we're going to set it to the encrypted amount. So, for example, if A equals C in the build shift dict, and the user has 4 A's within their message. Those will all become C's. It's going to go through this and change it to the predefined dictionary amount. And then we're going to return the new encrypted variable here. Or it'll do it in reverse with the predefined cipher, but essentially it's just going to take that shift amount that's been defined in the dictionary and change it to the message or plain text, just kind of depending on what the user will do. And then that is both of the methods for problem 1. Thank you. Have a good night. All right, I guess I'll see you for problem 2. Thanks.